Hello everyone, welcome to Epsilon Pro Academy. In this lesson, we are going to consider quotient rule, which is one of the rules in differentiation. In our previous video, we have discussed about the concept of function of a function, and we have also talked about chain rule, and also we have discussed about product rule, how to identify them in a question, how to solve problems related to product rule, and principles that must be applied when you come across a product rule. Again, how to solve question under product rule with the combination of chain rule together. So if you haven't watched our previous video, you have to do that for a proper understanding with regard to today's lesson. So when we say quotient rule in calculus, we are talking about a function being divisible by another function, a function divided by another function. So basically, quotient rule talks about a fraction, a vulgar fraction, where we have a numerator and where we have denominator. Examples of quotient rule is that if y is a function of x, then y should be equal to x squared plus 2 or divided by 2x squared plus 1. Another example is y is equal to 4x plus 3 divided by 2x plus 3. Another example of quotient rule, it could be, let's say this number 3, x squared plus 9 or divided by sine square x. Another example of a quotient rule is 3x squared plus 4 raised to the power of 2 divided by 2 sine 2x. So this is an example of quotient rule on the board. It is always a function divided by another function. And also, if y is a function of x in quotient rule, then we can represent y to be u over v. This is quite related to what we considered in product rule. But just that the difference between product rule and quotient rule is that product rule is when a function is being multiplied by another function. That was when we stated that y is equal to u times v. But in quotient rule, the case is that a fraction must be attained. It must be a numerator over denominator. Then the numerator should be represented using letter u, and while the denominator should be represented using capital letter v, respectively. So, for example, if you are considering the first function on the board, where y is a function of x on the board, then the numerator becomes u, while the denominator becomes x. In the second example on the board, where y is a function of this, the numerator is u and the denominator becomes x. So that means u is equal to this, 4x plus 3, and v is equal to 2x plus 3, and so on. Then, generally, if a function is given to us and we are required to determine the derivation of that function with respect to the independent variable, then dy over dx is equal to v du over dx minus u dv over dx all divided by v squared. Now this is the general formula for quotient rule. Now we are going to consider some examples using this formula given to us on the board to solve. Let's consider question number 1 on the board. Question number 1, let's say y is equal to 4x raised to the power of 7 plus 2x cubed all divided by x squared plus 1. So now the question is find dy over Nigerian chalk over dx. Find the y over dx. Now, this is quotient rule. How do we identify it? We identify quotient rule by the expression in terms of a vulgar fraction. A quantity or a function divided by another function. Now, how do we approach quotient rule? To approach quotient rule, the first thing we have to consider is to change the equation into this form, where y is equal to u over v. If that is so, then let us do the same here. Y will equal to u divided by v. If y is equal to u over v, that means the numerator is equal to u and the denominator is v. So my u is equal to 4x raised to the power of 7 plus 2x raised to the power of 3. Then v will equal to x squared plus 1. X squared plus 1. Now the next approach, from the general formula given, let's find du over dx. Now the concept is very simple. This is the concept for derivation. If I'm required to determine or to find the derivation of a particular function, that is to say, an equation must be given to me. Now in that equation, I told you that a function must have two different letters present. It must be 2. So in the equation given to me, the derivation becomes the dependent variable divided by d, the independent variable. So on the board, I have du over dx. So I'm going to consider an equation that has only u and x in them, and which is this, u and x alone. So that means du over dx will equal to, now let us recall the formula for derivation. In derivation, if we have y is equal to ax raised to the power of n, then we said that dy over dx will equal to anx raised to the power of n minus 1. So that means use the power to multiply with the coefficient, then subtract 1 from the power. That is very simple. So let us apply that into this and also this. So that will give me 7 times 4, which is 28, x raised to the power of 7 minus 1 is equal to what? 6. Plus, apply the same formula here. 3 times 6 is equal to, 3 times 2 rather is 6. So it's 6. Then subtract 1 from the power, x raised to the power of 2. We are done with du over dx. Then the next is dv over dx. So dv over dx, we're going to consider this equation, v and x. Applying the same formula or formula for derivation, we have that dv over dx will equal to, the power is 2 and the coefficient is 1. If you see a quantity without a number attached to it, then there's an invisible one which was omitted. So that is 2 times 1 is going to give me 2x. Subtract 1 from the power, it becomes 1, which is this. And the derivation of a constant term is always equal to 0. So we obtain 2x as dv over dx. Now dy over dx from the product rule formula is equal to dy over dx will equal to v, and v is given as this. So we have x squared plus 1 times du over dx, and du over dx is given as this. So times 28 x raised to the power of 6 plus 6x squared. Then minus, we have u. So u is given as 4x raised to the power of 7 plus 2x cubed. So we have 4x raised to the power of 7 plus 2x cubed times, and the next is dv over dx. dv over dx is 2x, all divided by v raised to the power of 2, which is v squared, and v is this, so we are going to take the square of this, x squared plus 1 raised to the power of 2. So this could be your final result, or you can further simplify the numerator. The numerator, yes. So if we are required to simplify the numerator, then it will be this bracket times this minus this times this, then you collect like terms. Okay, let's do that. From the numerator, x squared times this will give me 28x raised to the power of 8 plus x squared times this will give me 6x raised to the power of 4 plus 1 times this is 28x raised to the power of 6, and 1 times this plus 6x squared minus, over here, multiply this by 2x, we obtained 8x raised to the power of 8 plus, multiply this by this, we obtain 2 times 2 is 4, x raised to the power of 2 plus 1, x raised to the power of 1 gives x raised to the power of 4. So this is all divided by x squared plus 1 raised to the power of 2. So we can further simplify the numerator. 28x raised to the power of 6 minus 8x raised to the power of 6 gives 20. So we have 20x raised to the power of 8 plus 28x raised to the power of 6, 28x raised to the power of 6, then this is x raised to the power of 4, this is x raised to the power of 4, so 6x raised to the power of 4 minus, the minus is affecting these two, minus 4x raised to the power of 4, that will yield plus 2x raised to the power of 4, then plus 6x squared, plus 6x squared. Okay, all divided by x squared plus 1 all raised to the power of 2. So this becomes the final solution.